Hello, lecturer and the teaching team. My name is Khoa. I'm from Group 3, and this is a group assessment video demonstration in embedded system, operating system, and interfacing of semester A 2025. So I will be a representative to give you a brief explanation of our code logic as well as the how we handle UART and frame buffer. So the first of all is the common, which is the logic when we handle and create new common for the system. So so as you can see in the CLI header files right here, we create a shook for our common. And the shook have pretty much everything about common, which is the name, description, the use set of detail, and a function that common will trigger when we use the common. And here is the maximum size of character that can appear in the attribute. So, and we do have like CLI init here. So for CLI init, so like we register the common to give it like which common name, how we use it, what is the description, what is the method gonna be shown when you use the help attach it in front of that. And lastly is a function that will be triggered when we use the common. Second is UART. So in this group assignment, we decided using UART0 because we saw that UART0 have more function than the mini UART, which is UART1. So for this UARTs, we using the mailbox to configuration it to 4 megahertz clock rate. And we also enable the GPL 15 and 14 for normal hardware flow. And second, we also enable the GPL 16 and 17 to enable a handshake command, which is the GPL hardware flow controlling. And for GPL 16 and 17, we're using alternative function number 3, which is RTX0 and CTX0. And here we toggle the clock, like enable clock for those GPIOs. And most important, we have to give a flag for a UART mode, which is enable UART mode, and then enable the RTX and enable CTX, as you can see here. So this is a flag to enable the CTX and RTX flow. And so we give parameter in the UART init. So it's including the baud rate and the UART mode. So for UART mode is the enum function, which is UART basic mode for normal UART, and UART mode flow CTL for RTX and CTX flow. So we give the parallel like this to handle when we want to change the baud rate of the UART, or we want to switch between normal flow controlling and hardware controlling. So I'm going to check for the mode and then give the UART the necessary register, as well as enable necessary GPIO. Okay, the next one is the frame buffer. So for the frame buffer, so we use the virtual screen and physical screen resolution. So both of them are going to be I believe it's 600 and 480, because our project didn't require much space between physical and virtual screen, so that's why we give it like the same resolution and no offset. As well as we have create like new function to draw a string. I mean, like to draw a string, like a string when we're using the font. So as you can see right here, when we try to display the name, display team name here. So show team gonna have so this is a routing function. So in the routing function, we're gonna take the font and so the X and the Y, which is the coordinate when we put the beginning of the first pixel in that font, and gonna check for the string, which is the string with input, like my name is Khoa, right? So if I put input to Khoa into this parameter, it's gonna bring a Khoa using the font app that we have implemented in the file right here. And the next one is how we register for a comment. So back to the CLI header. So here, as you can see, we have a CLI init function. So in this function, basically it's just register for a comment. So the register comment basically just add a new object, which is a new object for the comment. So as you can see here, the as you can see here, register for comment, register comment here. So the register comment basically just gonna receive the name of the comment, the description, and how the syntax of user should use it, and also the function that's going to be triggered when we use the comment here. So for the display image, so we have a different description for it because it's kind of long and it's not it's kind of long, so we want to separate it to have better optimize our code project. And this is a Mac file. Then we're not using the yard one anymore, but we gonna still put it here. And but when we make when we try to make the file, we only use the yard 0. As I said before, yard 0 have more feature than the mini yard, which is yard 1. And for mailbox, so for the mailbox, so mailbox is necessary for getting the board information, such as board revision, the MAC address, and also to set the baud rate to some specific number. Yeah, some specific number. And this is our font. So basically, I get this font from internet and then using Python to extract the bitmap, which is the clean bitmap font format to input into this file right here. Yeah, and that's pretty much all of the brief explanation of our project. So thanks for listening.
Hello, my name is Nguyen, and now I'm going to show you a product running on the QEMU. First, I'm going to type make to start the product, to start the project. And next is going to print out the uh, course name and our team members on the POS on the terminal, like this. Yeah, here, the POS. The POS. And next, we're going to type help to show the list of the commands in the briefing way. And if we type help with a specific command like show info, it will show the specific information of that command or display image. Yeah, it will show how the function work and all the variables images that we can show. And next, if we hit clear, this will clear everything we have right. And if we type show info, it will show the information, the board revision, the values and the information of the board. And if we type in board rate with a specific value, 960, is we change the board rate to 960. And same with the other values board rate, like 150. 1152. Yeah, so change back the baud rate, and then if we can also make the handshake on and the handshake off, and we also have the auto completion. Uh, First, when we type show, it will when we hit type, it will show the every commands that start with show. Yeah, because it's not the that not the only one command that start with show, so it will show the list. And if we continue to complete it and hit tab, it will autocomplete with the show team. And here's the show team function. And next, got the display image, like Bowen. Here, yeah, we can here see the Bowen and display image. Bearing 2. Yeah, here. And we also have the function for the command history, which is we hit the shift minus. Here it will show the previous command that we have used. And yeah, like that. And for the shift plus, it will show the after command like this. Yeah, here like that. And that's all for the functions of the products we are using. Thank you very much.
So for the video on Kimu, so our group decided to use 50 frame per in totals for the videos, and the delay per each frame was 150 millisecond. And our resolution for the video was 400 and 225 in width and height. So let me run it for you to see first. So this is a video running on Kimu. As you can see, all the color correct, and also the video running smoothly, as well as the expected time we calculated for 50 frame per total as and 150 millisecond delay for each frame was matched.
Hello, my name is Khoai. I'm in group 3. So today I'm gonna demo our final project on the report. Yeah, let's check our final project. I'm gonna start the hold up. Yeah, just wait a little. You can see then our project startup, and you can see the course name, display with OS, and our team information there. Let's get started. So there's a lot of comment there. So I'm gonna first have to check all the comment. You can see that a lot of comment the have clear showing for portrait handshake. I'm gonna go through them one by one. So first is the clear. Let's check clear. Yeah, sorry, clear there. Yeah, just clear our terminal. So about show info, with there. The show info that show that our board is the Raspberry Pi 3B. The memory is 1 GB, and the manufacturer is Sony UK PCB, and my address. That show all the info of our board. So let's see. Oh, the show teammate. So you can see. Let me show. So let me a bit. So about the show team, I'm gonna show the team on the OBS. Yeah, you can see there. And you can see that I show my team on the OBS, like my team formation, the SID, team tree, and even the IoT logo. So next, it's gonna display image. About this maybe we have plenty of image, so I will show them through the head display image. You can see that we have a lot of features. So I'm gonna show one of them. So it's gonna be I think it's library. Let's see there. That's the picture of the library. And maybe the trim. You can use the control and the minus the minus button to show the history, show the history there, and the minus and the plus button show the history. Yeah, I'm gonna show the W2. Yeah, you can see it. Next is our our command, the play video. Yeah, it just show a video of about 5 seconds, 5-6 seconds over here. Yeah, now see it. Yeah, that's a video. That's our video. And that's the final of my demo on the report. So thank you for listening.
Okay, so for the bow rate and the handshake feature, I want to demonstrate and add a little bit, extra note on the how the user should use that. So first, gonna clear terminal to make it more tidy. So for bow rate, first of all, bow rate. So let me tap help comment for the bow rate. So the bow rate said you can change the bow rate of current UART that you are using. So for example, if I change the bow rate to like 9600. So at the currently the UART we are using right now is running on 9600. So that's why we cannot input anything into the third term right now. Yeah, I'm spamming the keyboard. So in that case, I'm gonna change the third term baud rate to 9600. And now we can type it in again. So let's try to display some image. So for example, image gym. Yeah. So this proof that our current our baud rate setting is working perfectly. So let's switch back to the 11,500. Okay, now since I switch back, so that's so right now my third tab is freezing and I cannot input anything into the terminal. So let's switch it back to 11,000. Okay, and then I want to test out the handshake flow between the UART. So let's say handshake on. So now I'm enabled the handshake, which is the CDS and RTX flow. So I can use the flow control RTX and CDS in the third term. Okay, I just enable that and let it test it out with the maybe show team again. Yeah, show team. Okay, so it's show team. So my team right here are the actual real board. Okay, how about I try to turn off the handshake? Okay, now and disable handshake so that as you can see now I'm spamming the keyboard and nothing is appear on the third term because I just turned off the flow. So that's why I have to switch back to the basic flow between UART, which is none, third term, and then new setting. So here, it display the reverse spamming message when I'm using the RTX CDX flow. So let's say I want to try to play video one more time. Okay, so as you can see, the board actually display a video on the screen right now. So that proves that our handshake feature are working perfectly and nothing goes wrong right here.
Hi, my name is Trung and I'm gonna walk you through the game of our Raspberry Pi. So in order to start the game, we need to press start game or game. So let's go to the help menu. So as you can see here, these are the two commands we can use to start the game. So they're the same, just alias. So start game and game. So now I will press game. Now this is the main menu of the game. We have two options, play and quick. In order to choose between the option, we can press W to go up and S to go down. So S, quit, play. So we can change between the two options here, so W and S. And in order to select the option, we need to press enter. So I want to press enter on play here. And before we start the game, here is the basic. We will have two main control, go left and go right. So A will be for going left and D will be for going right. So now let's start the game. So moving left. So if we hit the wall, it will automatically go to the opposite direction. But if we, oops, that's the worm here. So but if we want to change direction, so we just press A or D depending on what you want to do. And when we have enough point, we will be automatically promoted to the next level. As you can see, we are on level 2 here. So yep, catch the apple. Yep, try to avoid the bomb. Catch the apple. So yep, let me go to the level 3. Yep, this is the level 3. So yep, this is pretty much the gist of the game. So now let me try to catch the bomb to get the game over screen again. So this is the game over screen, and if you want to play it again, we can press R. So we'll go back to level 1 here. So you can see the level and the score on the top right corner. Yep. And if you want to pause the game, we can press P. So, and if we press R, we will resume again back to where we are. So pause, resume, pause, resume here. And yep, that should be it for the game section here. And if you want to quit the game, just press Q. Yep, and that's it. That is the Apple game. Yep. Okay, so now this is the setup with the board and a real monitor. So I have my Raspberry Pi connecting to the laptop via the UART port. So you can see it here, the UART port right here, connected to the laptop, and I'm using screen to display the terminal of the Raspberry Pi. So I can show you now. I will type help here. So now this is the all the same commands we have here. So for this demonstration, I will play game. So put it game here. So, and you can see this is the monitor. This is the game screen here. So again, the same command, play and quit. So let's play it a bit. So this is the game. So basically everything is the same for the real board here, as you can see here. So the same movement left, right. You can see the command here. You can see the data here. So in the terminal. So moving left, right. Apple collected. Yep. Okay. And so let's just pause it a bit here. So now I will quit the game. So quit the game. Tap help again. So now I will demo a video, play video. So as you can see, we have the play video. The video is being played on the real monitor here. Yep. So that should be the demonstration of the real board on a real monitor. Thank you for listening.